Hello learners, I am Dr. Subodh Kesharwani, working with Indira Gandhi National Open University in School of Management Studies. The topic which I am going to talk today is regression analysis. This is part of our course called MCU3, Research Methodology and Statistical Analysis, and we are here to discuss about regression analysis. In our preceding session, this is part of our chapter called Unit 10, and which talks about regression analysis and correlation. So correlation we have already covered in our preceding sessions, and we have seen that how the correlation is playing a very important role when we are talking about the relation between the two variables. And if you see into the backdrop, we have talked about the correlation. We have talked about scatter diagram, the correlation coefficient as far as the Karl Pearson correlation coefficient is concerned, or testing for the significance of the correlation coefficient is concerned. And then the Spearman rank correlation had been taken care. And in this particular chapter we have two components that I have already talked about, correlation and other is regression. And as far as this particular presentation is concerned, we will discuss exclusively about regression analysis, and we will see that how regression analysis is going to be useful when you are going to talk about the correlation, when you are going to talk about the difference relationship between the two variables. So let's start with the differences or relationship. I think when we are going to talk about differences, differences is going to examine when there are two groups are there, and for that we are using t-test or ANOVA test. And when we are talking about correlation or regression, I think when there is a relationship between two variables, in that case the correlation and regression analysis is going to be taken care. So let's recapitulate what we have already done in our preceding sessions. We have as far as this particular chapter is concerned, we have seen that a correlation analysis provides information on the strength and direction of the linear relationship between two variables. So there is a linear relationship between two variables, while a regression analysis estimates parameters in a linear equation that can be used to predict values of one variable based on the other. So there is a vast difference between one. As far as the correlation analysis is concerned, it's going to talk about the direction of the linear relationship, what could be the shape of the relationship, and when you are going to estimate the parameters and you are going to predict values of one variable based on the other, for that the regression is going to play a very important role. And we have seen in the scatter diagrams that how this scatter diagrams looks like. When we talk about the positive, it starts from left to upward right, and when we are talking about this negative correlation, it is from upward left to downward right. So, and when there is no correlation, you see we are not in a position to develop a line. So this is the way. This is called positive correlation, this is called negative correlation, and this is called no correlation. So anyway, scatter plots, we have seen that how it is going to play a very important role as far as the correlation is concerned. So in our previous presentation, or when learners can recapitulate themselves, or they can visit the correlation presentations, they will find out that how we have studied the scatter plots and correlation, but regression is one step ahead to that. And that is the reason we have put the exclusive session on regression analysis. So we have observed that scatter plot is used to show the relationship between two variables, and correlation analysis is used to measure the strength of the association, that is linear relationship between two variables, and only concerned with the strength of the relationship. So what we observe that when we are going to talk about the correlation, it is emphasized more on the strength of the relationship, and there is no causal effect implied. So there is no causal effect implied. That is the reason we are moving towards the regression analysis. So the correlation measures the degree to which the set of data points form a straight line relationship, and regression is a statistical procedures that determines the equation for the straight line that best fits a specific set of data. So regression is purely a statistical way of doing the things, and with the help of equations, with the help of straight lines, we are able to find out the best fits a specific data. So correlation tells you if there is an association between x and y, but it does not describe the relationship or allow to predict one variable from the other. So this is the biggest stumbling block the correlation have. And when we are going to talk about regression is giving you many things. So let's start with the regression analysis. Regression analysis is a form of predictive modeling technique which investigates the relationship between a dependent target and independent variable predictor. So what we have observed that it is in the form of predictive modeling, and the technique is used for forecasting, time series modeling, and finding the causal effect relationship between the variables. And this is the very important aspect, that it is going to explore and find out the causal effect relationship between the variables and the relationship between rash driving. And there are some very good examples, and this causal and effect relationship is like, when we are going for the rash driving, a number of road accidents by drivers is best studied by through regression analysis, because more you do the rash driving, more there could be number of enhancement in the road accident, so by the driver. So this is one of the cause and effect relationship which force the the analyst to go for the regression analysis. So, and when we are talking about the predictive modeling uses statistics to predict outcomes. Most often event one wants to predict is in the future, but predictive modeling can be applied to any type of unknown events regardless of when it is occurred. So this predictive analytics is based on the data reporting analysis, monitoring, and predictive analytics, and what happened, why that happened, what is happening now, and what is going to happen in near future. So this is all things which is going to be part and parcel of predictive analytics, and we will see that how this predictive analytics is quite useful when you are going to talk about the regression analysis, because there are certain tables, there are certain this equations or the formulas. With the help of that, we are going to maintain that. So assumption is based on the linearity. The linearity is the y variable is linearly related to the value of x variable. And when you're talking about independence of error, the error residual is independent for each value of x, and homoscedasticity, the variation around the line of regression, be constant for all values of x. So this is called homoscedasticity, and normality is the value of y be normally distributed at each value of x. So these are certain assumptions which we are going to formulate or start working on the regression analysis. So types of probabilistic model, I think while going into the depth of this model, we have already covered the correlation models in our preceding sessions. Regression model we are covering here, and there are some other models, but when you go into the backdrop, you will find out that all comes under the ambit of probabilistic models. So probabilistic model incorporate random variables and probability distribution into the model of an event or phenomena, and while deterministic model gives a single possible outcome for an event. So probabilistic model gives the probability distribution as a solution. So a regression model is one of the important ingredients of probabilistic model, and this regression model emphasize, or what we can say, that it's a relation between variables where change in some variables may explain or possibly cause changes in other variables. So cause and effect relationship is a very important term which revolves around this particular model, and explanatory variables are termed the independent variable, and the variables to be explained are termed as the dependent variable. So regression model estimates the nature of the relationship between the independent and dependent variable. It's not like that we are just emphasizing on the dependent variable or independent variable. So when you are applying the regression model, it estimates the nature of the relationship between the independent and dependent variables. So change in dependent variables that results from changes in independent variable, that is size of the relationship, strength of the relationship, statistical significance of the relationship. So when you are going to talk about this regression model, I think it estimates the nature of the relationship, and dependent and independent variable is a very important ingredient. So relationship between one dependent variable and explanatory variables is an ingredient of regression model, and we are going to use equation to set up the relationship. Numerical dependent, or we can say the response variable, and one or more numerical or categorical independent explanatory variables. So this is used mainly for prediction and estimation. So that is the reason we say that in the regression model we are mainly emphasizing on prediction and estimation. If you see these regression modeling steps, I think hypothesis, deterministic component, this estimates unknown parameter and specific probability distribution of random error term and estimated standard deviation of error. So there are statistical deviation of error is there, and we will talk more about it, because the standard error is one of the important way by which you are going to complete the whole equation. So evaluation, the fitted model, use model for prediction and estimation. So regression analysis is about a mathematical measure of an average relationship between x and y in terms of original units of data. The average mathematical relationship is utilized to help estimate the expected value of the dependent variable based on an unknown value of the predictor. That makes regression analysis a reliable tool for forecasting events. For example, a company future sales can be estimated using past records. So this is a way by which we are going to do that, and regression analysis implies that the outcome depends on one or more other variables. So these are the constraints. If we go into the backdrop, and we will see that when we have covered the correlation, I think there also we are finding out the relationship between the two variables, but here the outcome depends on one or more other variables. So X predictor, prognostic, explanatory, or independent variables are there, and horizontal axis of a graph is used for plotting the independent variable, and the outcome may be called the dependent variable, and criteria or response based on the criteria and response, it is plotted on the vertical axis. So linear regression is what? If we start with the linear regression or the simple linear regression, in correlation the two variables are treated as equal. In regression, one variable is considered independent, which we call the predictor variable, and x and the other dependent is called the outcome. So here we are treating the two variables in a different manner. In correlation, we considered the variables in an equal manner. Either it could be x or y or a or b, but in regression one variable is considered independent as predictor and other the dependent. So one variable is considered independent, which we call the predictor, and other the dependent, which we call the outcome variable. So the example which I have quoted was best fit here, that if you do a rash driving, there will be chances of more accidents. So we are predicting, and on the basis of that, one is independent, another is dependent, and one is giving the outcome of that. So what is linear? Remember this: y is equal to mx plus b, and if we are going to plot this on a x-axis or y-axis, I think we have got horizontal lines and we have got a vertical line. So vertical line would be considered y and horizontal line would be considered x. So then we are going to plot this, and this is what the thing is that that m is coming, and if you see this particular image, you will find out that y is equal to mx plus b, and this is called equation. So a slope of 2 means that every 1 unit change in x yields a 2 unit change in y. So this is called a slope, and when you are talking more about the prediction, if you know something about x, this knowledge helps you to predict something about y, and sound familiar, sound like conditional probabilities and other thing is there. And the regression equation, I think expected value of y at given level of x is e y x equals to alpha plus beta x, and predicted value of individual is alpha plus beta x plus random error. Standard, this is called standard error, and we have a exclusive session, we have a dedicated session which talks about how this standard error is going to part and parcel of the equations or the regression analysis. So if you see this particular predicted value of individual, you will find out that fixed exactly on the line and follow the normal distribution. So assumption is that line regression assumes that the relationship between x and y is linear. Y is distributed normal at each value of x. The variance of y at every value of x is the same. That is homogeneity of variance. The observations are independent. So now you see this particular thing, that in one axis we have independent and other axis we have got dependent variables, and this is called the regression line. This red line starting from this point 0 is considered to be a regression line, and all these are the variables, and the line could be best intersecting the different dots. So you will find out this is the estimate and this is the actual, and errors are also there. So once you, and this is the way by which we are going to calculate, and that is the reason the term called best fit line is there, and aim of the line regression is to fit a straight line, that is y is equal to ax plus b, to data that gives best prediction of y for any value of x. And we have seen that this is called slope, this is called intercept, and y is predicted value, and green is called yi, true value, and residual error is also there, so which we usually call the standard error. So this will be the line that minimize distance between the data, and fitted line, that is the residual value. Now, why we need regression analysis, that is an important aspect. We have already have a very preliminary session, or rather we can say the curtain raiser to regression analysis, and now we are talking more about why there is a need of regression analysis. So regression analysis is used for these purposes, like prediction of the target variable, forecasting, modeling the relationship between the dependent variables and the explanatory variable, testing of hypothesis benefits, and it indicates the strength of impact of multiple independent variables on a dependent variable. It indicates a significant relationship between dependent variables and independent variable. But on the other hand, there are certain benefits also. It helps market research, data analysts, data scientists to eliminate and evaluate the best set of variables to be used for building predictive models or the predictive modeling. So this is the beauty of the regression analysis, that it's evaluate the best sets of variable, and regression analysis is a tool for building a statistical model that characterize relationship among a dependent variable and one or more independent variables, all of which are numerically taken care. So simple regression analysis involves a single independent variable. Multiple regression involves two or more independent variables. So this we are going to discuss in a more elaborative manner in a forthcoming session, the types of regression analysis, where you will find out that the part 1 talks about the simple linear regression analysis, and part 2 talks about the multiple regression analysis. So this is a very important aspect, because with the help of formula, with the help of certain equations or derivatives, we are going to solve the equations. So purpose of regression analysis is to analyze relationship among variables. The analysis is carried out through the estimation of relationship, and the results serve the following two purposes. So one is answer the questions of how much y changes with changes in each of the x, and y is the dependent variable. So forecast to predict the value of y based on the values of x, where x is the independent variable. So what we have observed that you have one dependent variable, you have one independent variable, and with the help you are going to formulate the questions or the equations and solve it. So set of data points fits a straight line. How well a set of data fits a straight line can be measured by calculating the distance between the 2 points and the line. The total error between the data points and the line is obtained by squaring each distance and then summing the squared values, and the regression equation is designed to produce the minimum sum of squared errors. So if we talk about the regression analysis is a statistical tool that gives us the ability to estimate the mathematical relationship between a dependent variable, usually called y, and independent variable, usually called x. This we have already taken care, and the dependent variable is a variable for which we want to make a prediction. And while various non-linear forms may be used, and simple linear models are the most common one. If you see this particular image, I think this is quite well versed as far as the explanation is concerned. The goal of the analyst who studies the data is to find the functional relations in y is equal to fx between the response variable y and the predictor variable x. So pictorial presentation of linear regression model, if you see, this is a line, and this is a regression line, which we can say, and probability distribution of y is this, and so this is the way. And the historical origin, if you see this, of regression analysis was first developed by Sir Francis Galton, who studied the relation between heights of sons and father, and heights of sons of both tall and short fathers appear to revert or regress to the mean of the group. And at one point axis we have taken father side, at the one axis we have taken the son side, and then population start is there, and then tall is there, and population average is going to be calculated by that. So construction of a regression analysis. Now Selection of independent variables. Now, since reality must be reduced to manageable proportions, whenever we construct models, only limited number of independent or predictor variables can or should be included in a regression model. Therefore, a central problem is that of choosing the most important predictor variables. So, functional form of regression relation is that sometimes what we observe that relevant theory may indicate the appropriate functional form, and more frequently, however, the functional form is not known in advance and must be decided once the data have been collected and analyzed. And as far as the scope of model is concerned, in formulating a regression model, we usually need to restrict the coverage of model to some interval or region of values of the independent variables. So now there is a use of regression analysis. So regression analysis serves three major purposes. I think the description, control and prediction. So the several purposes of regression analysis frequently overlap in practices, and once we solve with the help of example, we see that it describes, its control and predict. So prediction is very important because in statistics, the whole statistics is based on the assumption or the hypothesis, and we have a very elaborative session which talks about what exactly the hypothesis is. Either it could be the null hypothesis or alternate, or the accepted or rejected. And after certain time, when we are going to test the hypothesis, I think there is a great impact of prediction, because the whole assumption is whole statistics is based on the assumption. If you have a right assumption, or if you have assumed the thing in a more systematic manner, you get a very concrete result which can be at par to the results we are expecting. So formal statement of model is like general regression model is y is equal to beta 0 plus beta 1x plus e, and this beta 0 and b1 are parameters, and x is known as known constant, and deviation e are independent to n, which also be considered as a standard error. So we have an exclusive session on standard error which talks about that. So meaning of regression coefficient is that the values of regression parameters, this beta 0 and b1 are not known, and we estimate them from data. So beta 1 indicates a change in the mean response per unit increase in x. So this regression line, if you are going to talk about, if the scatter plot of sample data suggests a linear relationship between two variables, that is y is equal to beta 0 plus beta 1x, we can summarize the relationship by drawing a straight line on the plot, and least square method gives us the best estimated line for our set of sample data. So we will write an estimated regression based on sample data as y is equal to b0 plus b1x. So the method of least square choose the value of b0 and b1 to minimize the sum of the square error, and the formula is n, total I is equal to 1, and y1 minus yi in squares equals to summation of I varies from 1 to n, and y minus b0 minus b1 x to the power 2. So anyway, I think this is an important aspect, and test for association between two variables, and the researcher determines neither variable, both are natural variable. If an association is detected, the inference is that variation in x may cause a change in y, or vice versa, or that variation in the third factor may affect both x and y. So testing hypothesis about cause and effect relationship is an important ingredient. And in our coming sessions, when we are going to test the hypothesis, we are going to use this phenomena. So linear regression helps in estimating the value of dependent variable corresponding to a particular value of the dependent variable. So now the thing is that how you are going to build a good regression model. All of the independent variables in a linear regression model are not always significant. So we will learn how to build good regression model that include the best set of variables. Like banking data includes demographic information on customers in the bank current market, and we will see that. And there are many types of regression based on the functionality. A simple linear regression helps to summarize and study the relationship between two continuous variables wherein y depends on x or x influence y. The best linear regression model is obtained by selecting independent variable with at least a strong correlation to dependent variable, that is greater than or equal to 0.8 or less than or equal to minus 0.8. So the regression line of y on x is expressed as follows: y is equal to a plus bx, y is the value for the dependent variable outcome, a is the regression constant, and b is the regression coefficient. The gradient of slope x is value for the independent variable. So Regression line is the least square line, is a plot of the expected value of the outcome for all the values of the independent variable. It is the best fit line. This we have already covered through the data points on a scattered diagram. Its slope is the rise divided by the run, is the point where the regression line would intercept the y-axis. So if the regression coefficient is significantly different from 0, the dependent variable may be predicted for any value of the predictor using the straight line method. However, because the regression model is not a perfect predictor, the equation contains an error term. So y is equal to a plus b plus error. So the standard error of estimate is the standard deviation of the data points as they are distributed around the regression line. The standard error can be used to develop confidence intervals around a prediction. So there are regression diagnostic also. The condition required for the model assessment to apply must be checked. Is the error variable normally distributed? Is the error variance constant? Are the errors independent? Can we identify outlier? Is multi-collinearity correlation between the X a problem? So this is called regression diagnostic. I think when we are comparing this correlation with regression, no doubt regression is one of the more predicted model, one of the more foolproof model, because it's based on the cause and effect relationship, and there are dependent variables and there are independent variables also. So no doubt when we are comparing correlation with regression, I think regression have got an edge as compared to the correlation. So in our coming sessions we are going to talk more about the types of regression. Either it could be the simple or the multiple in a more elaborative manner. Thank you very much.